This is problem 25 of chapter 11. It's another simulation example. So here we have a couple that want to have both a boy and a girl. So if they decide to continue to have children until they have one child of each gender, at least, I think it means at least one child of each gender. This is kind of weird language, so anyway, it's easy to get hung up on it, but I think you know what we mean. We mean that they have a girl and a boy, at least one of each. Okay, so the component is just having a child. It sounds simple when you write it that way. The outcomes are either a boy or a girl. Okay, and let's see, the description is, so let's think about the assignments. If you're doing a homework problem at home with a calculator, you could say, okay, we're going to let 0 be a boy and a 1 be a girl. And you could do ran int from 0 to 1, and you could just generate numbers until you got 1 0, at least 1 0, and at least 1 1, and then you would stop and your outcome would be 4. Okay, for that trial, something like that. Okay, so this would be maybe for homework. Now if we did that, if you come down here and you look at the numbers, you can see that we don't have that many 1s and 0s, so it's going to consume a lot. I guess it would work, but it's going to consume a lot of numbers. So, and you'd have to ignore everything. So what we could do to be a little bit more efficient with the numbers, we could say let 0 to 4 be a boy, and let 5 to 9 be a girl. Okay, so here we will generate random 1-digit numbers to simulate having children. Electronic pen. Using the assignments above to determine gender. We will stop once there are, is that the right word? Are one male at least, wait, there are at least one male and at least one female. Okay, I think you know what I mean, but try to be as explicit as possible. Okay, so what are we going to do? We're going to count the number of children to get at least one male and at least one female. Okay, so the notation, we're going to use male, M for male, and F is going to be female. Okay, so here we go. Let's have some babies. So a 5 would be a female, and then a female, and then a male. Okay, so that's 3. Okay, and then we have a 1, so that's a male, and then we have a female, and then we're done. Right, that's 2. T2. Once again, we have a male and a female, so 2. And then we have, let's see, a male and a female, so 2. T4. So I got a 4 here, so that's a female. No, that's a male, and then a male, and then a female. So that's 3. T5. So then we have 2 again, male, female, T6, and then we have male, female, 2, T7. Doesn't look all that bad, does it? Male, no, female. This time it's female, male, female, male, different order. T7, T8 is a 2, and then it's like female, male, 9, and then finally male, 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 finally a female. Oh my God, it's a big family, all those boys. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so let's see. We could add them up. We got 3, 2, 2, 2, 3, 2, 2, 2. So we have 6, 6, and 6. 18 plus 9 is 27. Okay, so on average, would be 27 divided by 10, if I did that right, so 2.7. If we were interested in max, let's see, until, if they decide to continue and have children until they have one child of each, what would the average, okay, so they're explicitly asking you for the average. Okay, so if you were planning a budget, like a financial budget, then you might want to know what's the maximum we should expect. So the maximum would be 9. So the question determines what kind of statistic you compute. Okay, so according to the simulation, we expect the couple to have, on average, 2.7 children. In order to get, or let's say to have at least one boy and one girl. Okay, so I added that up quickly. I'm pretty sure though that that's this is 7, 10, 12, 14, 16, 18, 27. Okay, so I did that right. Felt like I was going kind of fast because of the video. So I think that's how you do it. Problem 26 is pretty much the same, only you're trying to get 2 of each. But this is, so, you know, if you did a simulation, this is kind of, you know, if you did a simulation, here's 1, 2, so obviously it looks like we'd probably get, how many 2's did we get? We got 1, 2, 3, 4, 5, 6. 6 2's and 2 3's. So 1, 2, 3, 4, 5, 6. 1, 2, and then 1. So we're going to get a skewed population, a distribution over time. We'll talk more about this, but it's going to be skewed. It's not going to be symmetric, I don't think, because you can't have 1, and the probability of just getting 2 of each seems to be within 2 is pretty high. Okay, let's just stop there. Quit goofing around.